In this video, we're going to talk about the closed interval method. Let's recall Fermat's theorem. Fermat's theorem said that if a function f has a local maximum or a local minimum at the number x equals c, and if the derivative f prime of c exists, then f prime of c must equal 0. Well, there's another way we can look at that same theorem. If f has a local maximum or a local minimum at x equals c, then c is a critical number of f. So think about that, how it's the same theorem stated a different way. Because either f prime of c does not exist, and if it does not exist, then it must be a critical number of f, or f prime of c does exist, in which case f prime of c would be 0, which would make it another critical number. So what this tells us is that a local max or local min is going to occur at a critical number of f. So that's going to help us find the absolute max and the absolute min of a function f on a closed interval. Recall that the extreme value theorem guaranteed that we could find an absolute max and an absolute min if the function f were continuous, but it didn't give us any method to find it. And this is our method now. So the first step is to find the value of f at the critical numbers of f in the closed interval. Then we find the values of f at the endpoints, f of a and f of b. And then we simply compare. We'll have a list of numbers to look at, and among all those values, we choose the largest to be the absolute max and the smallest to be the absolute min. And that's all there is to it. So let's look at some examples. Let's find the absolute max and the absolute min of f of t equals cosine of t, where t goes between negative 3 pi over 2 and positive 3 pi over 2. What was our first step? Oh yes, find the value of f at the critical numbers of f in a, b. So to find the critical numbers, we're going to take the derivative. F prime of t will be negative sine of t, and we'll set that equal to 0. Now we have to be careful to make sure the derivative is defined at every value in the domain of f. And in this case, the derivative is defined for all real numbers. So the only critical numbers are where the derivative equals 0. So solving that, where is sine of t equal to 0? Well, at negative pi, 0, and pi. Now, of course, there's an infinite number of values of t. Any integer multiple of pi would be a 0 of the function sine of t. But we're only going to choose those values which belong to the interval from negative 3 pi over 2 to positive 3 pi over 2. So I don't just find the values of t, I have to find the function values. So my function is cosine of t. So cosine of negative pi is negative 1. Cosine of 0 is 1. And cosine of pi is negative 1. So that's step 1. Step 2 is to find the function values at the endpoint. So the function value at the left endpoint, which is negative 3 pi over 2, would be cosine of negative 3 pi over 2, which is 0. And the function value at the right endpoint, that would be cosine of 3 pi over 2, that's also 0. So that's step 2. In step 3, we just look at the numbers that we found in step 1 and step 2. The largest is 1. So the absolute max is 1. And the absolute min is -1. All right, let's look at another example. We want to find the absolute max and the absolute min of this cubic polynomial, f of x equals x cubed minus 6x squared plus 5 on the interval -3 to 5. Step 1, we'll find all the critical numbers and find the function value at those critical numbers. So take the derivative, set it equal to 0, and solving, we find that there are two critical numbers, x equals 0 and x equals 4. Now, both of those critical numbers are in the given closed interval from -3 to +5. So I'll use both of them. If there was another critical number and it was not between -3 and +5, then we would simply ignore that critical number. So the function value at 0 is going to be +5, and at the function value at 4 is going to be -27. So in step 2, we'll find the function value at the endpoints. At the left endpoint, f of -3 is -76. And at the right endpoint, f of 5 is -20. So now, last thing we have to do is just among those values that we found in steps 1 and steps 2, the largest one is 5. So that is our absolute max. The smallest one is -76. And that is our absolute min.